This is Mr. Precella working some financial mathematics problems with his Math 1324 class, and this is a summary review assignment, if you will, where we have a variety of different problem types, including a variety of which we use all these formulas, the simple interest formula, compound interest formula, and the annuity formulas, both present value and future value. These are the formulas that might occur or it might pop up while you're working on these homework. And there's already videos on the assignment. We already have videos for problems 1, 2, and then the really involved problems like 13, 14, and 15. And so I'm just going to go through and for the remainder here just sort of talk you through and help you choose or to try to decide which formulas you're supposed to use. Like problem number 3. So we're just going to decide which formulas you use. At this point, none of this should be new to you. We've been working a lot with this financial math. So number 3, I'm starting with that because problems 1 and 2 have already been done with the video. I already have a video working those out. Problem 3. A student borrows $2,000 at 15% for 6 months to pay tuition. Find the total amount due. Well, which formula should we use here? Is this an annuity? That would be the first thing that I would ask, and the answer would have to be no. This is not an annuity. There's no mention of any sort of periodic payments. It sounds like the person just borrowed the money and is going to return it in in 6 months' time. He's going to repay the $2,000 plus the 15% interest. Okay? Is this so? If it's not an annuity, then it's none of those. It's certainly not an effective rate problem. Does it mention anything about the interest being compound? If not, then it's a simple interest problem. And nowhere does the problem say anything about compound interest. So this is a simple interest problem. You want to find the total amount due. This is on problem 3. Just use the simple interest formula to calculate I equals PRT, the simple interest. And then it's not asking you how much interest is paid back. It's the total amount due. So you would use simple interest first, and then A equals P plus I. This is the future value equals the present value, that's the $2,000, plus the interest. So on this one, you're using I equals PRT, calculate the simple interest, and then A equals P plus I. Hopefully it's clear to you why we're not using an annuity. This is not an annuity. There's not a series of equal periodic payments. What about number 4? All I'm doing here is just sort of talking through what do you use to set it up. Find the amount necessary to fund the given withdrawals. Quarterly withdrawals of $950 for 8 years. Interest rate is 4.3% compounded quarterly. So how much should we use, or which formula? Is this an annuity? Is there a series of equal periodic withdrawals? Yes. There are quarterly withdrawals. Okay? So this is an annuity. So because of the series of equal withdrawals, equal periodic withdrawals, it's an annuity. So are we talking about the present value or the future value? See? Here's our 3 annuity formulas that might pop up. future value of an ordinary annuity. That's ordinary annuities are where the payments are at the end of the period. That's how most of the annuities are. Future value of an annuity due, and the present value of an ordinary annuity. I'm not making you use the present value of an annuity due formula. So, what do we find the amount necessary to fund the withdrawals? Do we want to know the amount at the end of the 8 years or at the beginning? Well, at the beginning. This one is a present value of an ordinary annuity. On that little formula listing that I have right here, but you should be able to find under document sharing on my math lab. It's this last one. P equals R times 1 plus I to the negative n all over I. And hopefully at this point R is the payments of $950, and hopefully at this point you know how to calculate lowercase I. That's the interest rate per period. And n is the total number of periods. So you divide to get I, 0.043 over 4, and you multiply to get n. Quarterly, 8 years. There's 4 quarters in a year times 8 years, 32 years. And all of these you should have already done problems like before you ever get to this point. Oh, let's see. Now this number 5 is just like problem number 2, and there's a video over that one. It's like number 2. In fact, it's exactly the same, but with different numbers. See, what about number 6? What's number 6? Find the amount of each payment to be made into a sinking fund, earning 5% compounded quarterly to accumulate $45,000 over 5 years. Payments are made at the end of each year. So here on number 6, here's my thoughts. Is this thing an annuity? Is there a series of equal periodic payments? Well, it says find the amount of each payment. So that's definitely an annuity. So, which annuity formula are we going to use? Well, payments are made at the end of a period, so that means ordinary annuity. So it's either future value or present value of an ordinary annuity. So let's see on this one here. I'm just sort of thinking my way through problem 6. Find the amount of each payment to be made. Okay, so we know it's an ordinary annuity. Into a sinking fund to accumulate $45,000 over 5 years. Where does that $45,000 go? Is it the amount of money at the beginning of the 5-year period, or is it some future value? It's the future value at the end of the 5-year period. So we know what it is. Which formula we're going to use. It's future value of an ordinary annuity. Okay? Future value ordinary annuity. S equals R times 1 plus I to the n minus 1 all over I. So number 6 is future value of an ordinary annuity. Future value ordinary annuity. What about number 7? An investment company. So I'm just sort of looking through the homework problems. The ones I haven't already done yet, I'm just sort of helping you decide which formulas to use. An investment company pays 5% compounded semi-annually. You want to have $11,000 in the future. How much should you deposit now to have that amount 5 years from now? So you want $11,000 in the future. That's definitely a future value there. The 11,000 is a future value. How much should you deposit now to have that amount 5 years from now? Does it mention any sort of periodic payments? How many deposits are you going to be making? Are you saving monthly for this 11,000? Well, no. How much should you deposit now? You're going to make only one deposit into it. So it's not an annuity. Okay? Is it so it's either simple or compound interest. It says compound, so this problem here is a periodic compound amount formula. A equals P times 1 plus I to the n. Use that formula for both parts here. The only difference is down here it's going to be 10 years. So what would you expect? Would you expect to have more? To have to put in more money to get to the 11,000 if you have 10 years versus 5, or less money? Well, you better be saving less then. Okay, you should be able to save less if you have 10 years for it to grow to the $11,000. So on both of these, it's a periodic compound amount formula, and hopefully you're following my logic. Why did I say it's not an annuity? Well, there's no talk about series of equal periodic payments. You're going to make one deposit now and then leave the money there. So it's either simple interest or compound interest. It says the word compound. Money's compounded semi-annually, so it's compound interest. Okay, so periodic compound amount. What about number 8? A company will need $75,000 in 7 years for a new addition. So let me go ahead. They need $75,000 in 7 years. That's clearly a future value. To meet this goal, the company deposits money in an account today that pays 9% interest compounded quarterly. Find the amount that should be invested. Does it talk about making payments into this? No. All they're doing is putting one lump sum of money. Find the amount that should be invested. To meet this company, they're going to deposit money in an account today. So they just want to put one lump sum in, let it grow to $75,000. So it's not an annuity because there's no payments. It's another compound interest problem. So on this one here, you use A equals P plus I to the n. Here the A, that future value is 75,000. So 7 and 8 are both periodic compound amount formulas. So number 9. Looking at number 9. Find the size of each of 7 payments. Oh, so it sounds like there's a series of payments. Find the size of each of 7 payments made at the end of each year into a 9% sinking fund, which will yield $71,000 at the end of 7 years. So it's a series of payments. That means it's an annuity. Talks about end at the end of each year, right here. So it's an ordinary annuity. This 71,000, is that a future value or a present value? Find the size of each of 7 payments made at the end of each year, which will produce $71,000 at the end of those 7 years. So this $71,000 at the end of the 7 years, that's a future value. So it's a future value of an ordinary annuity. Okay? Future value of an ordinary annuity. Do y'all need me to write it down? S equals R times 1 plus I to the n minus 1 all over I. What about number 7? Oh, wow. Not number 7, number 10, I mean. Number 10, it says find the present value of an ordinary annuity. It's telling you which formula to use. The present value of an ordinary annuity. So that one, there's not a lot of work to decide. P equals R times 1 minus 1 plus I to the negative n all over I. Number 11. Number 11 is going to be a two-part problem, it looks like. A man deposits $15,000 at the beginning of each year for 16 years in an account paying 6% compounded annually. So this is a two-part problem. Number 11. Man deposits $15,000 at the beginning of each year for 16 years. Well, it says beginning, and there is a series of payments. He's depositing $15,000 at the beginning of each year for 16 years. Since it says beginning, that's leading me to think annuity due. So this first part of the problem, we're going to use the future value of an annuity due. I remember doing a video, doing this problem with different numbers in a previous video on a previous assignment. Okay, I think on assignment number 6 maybe. He then puts the total amount on deposit in another account, paying 8% compounded semi-annually for another 15 years. So at this point on the second part of the timeline, he's no longer making the periodic payments. It's no longer an annuity. He uses the future value of an annuity due. This is on the first part. Oops. This is where you assume one more payment and then subtract that payment. S equals R times 1 plus I to the n plus 1 minus 1 all over I minus R. So to do the first part of the problem, it's the future value of an annuity due, and then the value you get for S here will then become the present value over here. On this other 15 years, you no longer have an annuity. It's just money sitting in the bank for 15 years. That'll be a present value over here. You're going to use the periodic compound amount formula here. For this P, it's whatever answer you got over here. Oh, let me lift this up. Can y'all see that? So, whatever you calculate for the future value of the annuity due on this part of the timeline becomes the present value over here. So 2 parts, and whatever you get for A, that will be your answer right there. Let's see. Okay, now 13, 14, 15 already have video, so let's see what number 12 is. Find the monthly house payment. Okay, to find a house payment, to amortize a 6% loan of $202,000. Hopefully you've got the hang of these calculating house payments. If the loan is for $202,000, that's the amount that you're borrowing today. That's a present value. To calculate house payments, you use present value of an ordinary annuity. Okay? P equals R times 1 minus 1 plus I to the negative n all over I. So to calculate a house payment, you use present value of an ordinary annuity. So this assignment here is not just intro. It's here where we're putting all of those finance formulas together. 13, 14, 15, there are videos for. You're using all of these formulas here. So you want to get familiar with this stuff. Okay? So I'm letting you use an index card on your test so you don't have to memorize these formulas. So you might want to write the ones that you don't know on your index card. Okay? And you just sort of have to know when to use which one, and that's what I was hoping I was helping you do with these here. Okay? That's part of the purpose of assignment number 8 here. So we're out of time now, so I will I'll go ahead and call it quits right now and work on this stuff. It takes practice, but these are some really good problems. So thanks for listening or watching, and have a good day.